Hello everyone, I am Junchan and welcome to the stream. Today I'm back working on the NBody simulation problem using Haskell and Accelerate, which is a bit of a pretext to try and do high performance calculation using Haskell. And well, it's been a while since we haven't coded any Haskell in the context of this stream because we've been, changing systems and also changing a couple of times. You're changing systems going from Windows to NixOS and changing development tools going from Haskell.nix, which is this titled Alternative Haskell Infrastructure for Nix Packages, to going back to something a little bit more, let's say, vanilla, because we bumped into an issue with Haskell.nix that was a little bit tricky related to template Haskell. And it really seemed like that there was no difference. Like we had Cabal build work outside of Nix Develop with the system-wide tools, but not inside Nix Develop with Haskell.nix. So I switched to what's called call Cabal to Nix, and let's go check it out. That would be here, I believe. Yes. So we are using here call Cabal to Nix, which in a way that's very similar to Haskell.nix, and which I think also what just inspired Haskell.nix, converts the .cabal file into a set of Nix dependencies and then builds the project with some ability to, for instance, override packages. So that's where we were stuck last time. We're trying to override some packages with equivalent versions that use what's called the don't check utility, which should allow the packages to build without using running the tests. And I'm realizing here that actually did a copy paste error here, but that wasn't enough to make things work last time. So let's try and get into a similar state and check that what we have doesn't work currently, and that would be in Accelerate example and doing Nix Develop. So that should source the flake file and, as I said, interpret the Cabal file. And here what I was hoping to do was to override the set of Haskell packages using an overlay and replacing Haskell LLVM native and Accelerate, Accelerated LLVM native and Accelerate by the equivalent version of the packages that but wrap with don't check, so that when it comes time to build, the Nix build would not run the tests written inside here. So that didn't work last time, so we need to dig a little bit deeper. And what we were following was nothing related to that. Yeah, the Nix Haskell development 2020 thread in the Nix discourse, which had Skyfold explain in detail a lot of potential tricks, including both how to use call Cabal to Nix and how to override packages with the don't check utility. But oh, I didn't see that there was this overlay thing here. But it seems like it didn't work for us, so we'll get to check that it indeed still doesn't work, and then dig a little bit deeper. And what was pretty good though so far was that it seemed that the Cabal to Nix picked up dependencies that Haskell to Nix didn't pick up, like CUDA and the NVIDIA X11. So we didn't even have to specify CUDA Toolkit or NVIDIA X11. This seems to be automatically found out. And so I'm not even sure how that comes about. But that's pretty nice. So let's see where it goes. And let's move this over there. I'll make that here, and let's see. Stream seems fine. Okay. Yeah, there we go. So that's the test suite. No feedback LLVM native, inside accelerated LLVM native. That doesn't work. No, NoFib test suite is disabled, so it's not that one. It's NoFib. No, it is NoFib LLVM native. So for some reason, it's both running, being disabled, and failing, which is a whole lot of contradictory things to be happening. So let's see. So is there another option here, which is to pass NoFib to accelerate? I don't know, but it would be nice to see whether we can introspect whether the package versions are the one that we expect. Okay, I'm actually, first of all, looking here, what's going on here. So I'm looking at the overlay and I see something strange. I see that things are being overlaid onto my Haskell packages here instead of final.haskell packages. So that doesn't seem like that's actually an overlay, really, unless I'm misunderstanding something. Or so meaning PKGs with that overlay shouldn't be modified, but my Haskell packages should have the new data, but not PKGs. So that's a bit strange. So I think I prefer our version, our way to do things, but then now I see also Haskell.packages versus Haskell packages. And are these the same things? Yeah, I also, in addition, use my Haskell packages here as well. Okay, so that's that should be figured out. Let's try next REPL with. Can we do it with the current flake? Is that even gonna work? What do we have in scope? It seems like we have the project dependencies in scope, which is pretty cool. So it seems it answers my initial question, which is, for instance, have we overlaid properly here? And I think we have. We just want, if we just print that, no. Load, not load, maybe not. Evaluate and print. Yeah, maybe we don't want to evaluate and print. So I think checks was null. It doesn't want to, but it doesn't want to do it for some reason. Don't know why. evaluate and print expression. Open a derivation. Okay, I wouldn't mind that. Has no source location information. Add attributes from resulting set to scope. Learning expression to scope. Instead results in current profile. Start mix shell. Shall we try that? S accelerate LVM native. Does not evaluate your derivation. It could be because these are indeed those are Haskell packages, so they're a little bit different. They get passed to this shell for but they're not built like Nix packages themselves. Do we have packages here? Pkg set. We got dot. We do have a shell.mix. So is that where we sourced? It could be that that's what we sourced in the end. Which where is that coming from? Yeah, I don't think we want something like that. I think we want to do something like the dot shell of the flake. I think def shell is going to evaluate and allow a dot shell to be created, I think. Now I'm wondering where is that coming from. And is that what our REPL is looking at right now? Project does techniques. So that sounds like maybe it's using the default .mix. Yeah. So is there a way to Nix REPL a flake? There is, but I suppose it's not evaluating anything. So we have all of the top level attribute set stuff available. So Nix REPL flake. Current workaround. Turing machine? What? Output equal apps REPL. Then you can do Nix run dot REPL. Interesting. Confnix, buildnix. Okay, so it's a similar get flake with whatever is in the local git repo. Interesting. Okay, let's try that. Outputs equal blah. Yeah, I think. I think we can give that a shot. Exit, or rather this, and dot REPL. Next run. Nine variable. There's the apps, and there's the default package. Which apparently the architecture can't be found. Don't know why. But there's the dev shell, which doesn't want to execute, but those things are there. And there must be packages too, right? Yeah. Okay, so packages dot r64.linux dot pkg. Yeah, because we have that only pkg, but oh wow, that just explodes. Okay, what happened there? Okay, I think my shell is needs a reset. Okay. Yeah, no, that's not what we wanted. We wanted this guy. Yeah, so we crashed. We crashed everything. Default system. DHT version. And well, I suppose I could simply put some of these things onto the output there, like my Haskell packages. And maybe packages too. Would that work? Yes. Okay. So yes, we should have accelerate LLVM native here, and well, both that one and the one in packages should be overridden. Okay, so if I say a equals this, then can I do a dot? I can, and then what? Check phase. Well, there is something in the check phase. So how do we know that the don't check has worked? Well, we probably need to find out what don't check does. I think don't we're supposed to have packages, right? Ah, right. Huh. Yeah, have I forgotten that somewhere? Is that possible? It's definitely possible, right? That pkgs also has the system prefix thing. Overlays should deal with that automatically, but pkgs here, that might not be the case. It might need to be prev. Because there won't be a .haskell there. Okay, definitely worth a shot. Here, yeah, this is a little bit strange as well. Okay, and let's check the don't check. And can we see the code for that? Let's see, can we print this? Okay, I think that gives us a sense of where it is in Nix packages. So let's go check that out. And the GitHub, Nix packages, GitHub. Okay, I'm not typing the correct thing. Packages, development, Haskell modules, lib.nix, and don't check. So it doesn't override cabal, and so there should be a do check. So let's see if there is a do check in A. There is, and do check is true. So it doesn't, we haven't properly overridden, which I suppose would be the case if, because we were using packages here. So let's see whether that was the error, and we at least have a targeted way to go back and introspect by ourselves. That's nice. And maybe we don't need to do a equal. Maybe we can just do check, and do check is true. So still not overridden. Let's see whether it's overridden in packages. And well, yeah, Haskell, and yeah. So do we mean Haskell.packages, right? Because what's up in there? Ah, right, we need the GHC version 8.10.4, and then we need accelerate, LVM native, and do check. And do check is true as well here. So definitely our overlay doesn't work. Well, it's good to have confirmation. Let's go check into how Nix overlays work. Make sure we have that correct. Data flow of overlays. Oh. Overlay 1 is something like that. And then applying the overlay is done by doing import Nix packages, inheriting some overlays. In our case, this, or doing overlays equal an array of things, and the things are functions of 2 arguments, passing self and super, or these days final and prev. So that's fine, except now we also try and overlay packages using the override function. And because some things are not overlaid in the same way than others. So let me think for a second here. There was a reason why we didn't follow the example like it was written here, where instead of doing what, to be honest, hold on 1 second here. Huh. this does feel like it's actually a, well, it doesn't use final, which I thought this thing used usually. So maybe it's just Haskell.packages here. Would that work? Hey. Package overrides missing. Maybe this is package overrides, not overrides. Apparently not. So let's double check on the syntax here. Here overrides seem to be, well, here there's a talk of compose extensions, so that's a bit tricky. Actually, override takes a function from one argument, and we definitely don't have that here. So I thought we reused something from elsewhere, but maybe we just simply forgot to add this function here. So let's add it. Old. And then here, presumably, there's some composition of old overrides or this. I don't know how that works. But maybe we just simply add it and we don't think too much. That's possible, right? Because it seems like it's actually passing a function from cell to super, and with the replacement of, well, here it's unclear. It looks like it's overriding maybe .lib, maybe? No, it's not clear what it's overriding. Let's take a look at what's in Haskell.packages and if there is GHC and GHC with packages in there. Well, packages definitely has we'd want the GHC version, so 8.10.4 is the GHC here. There isn't. So I think this is another override syntax for something slightly different. That's what we're trying to do right now. You don't need to do something like the following. I recommend most people use shell for works or project with multiple packages. Maybe. Oh, here, do check. Super Haskell packages override here, which is different than Haskell.packages override. But you know what? This says that it disabled tests for all the revisions at once. But it might be a bit of a blunt instrument, but I'm quite tempted. I am quite tempted. And part of me thinks, nah, you want to know exactly how to override something specific. Okay, part of me, okay. I'm listening. Let's try and find out how to do it. Okay, so I think we need to refer to other examples, but we couldn't find any other example with proper overlays, right? What we found were, I mean, this is one of the pretty developed, no, this is make packages, so this is not an example. This, however, is. This is a cookie cutter template that's been improved by Skyfold. So, but I think it doesn't have the whole don't check stuff. It has just static executable. Which is slightly strange. But it doesn't have the don't check stuff. Maybe we can find something that's not a fork, where maybe there's a more detailed default.mix setup. Inherit projects, inherit packages, comes from the top. Also uses kebab.mix, but it doesn't seem to overlay or do any special thing on top. Hey, Nix Workshop. Let's go web server and the Linux file in there. So hold on, is there a branch with like the solution or something? Maybe it's not finished. Ah, yeah, solution. Build project and default.mix. Deploy to VM. Wow, deploy. There is an override here, but that's yeah, that's not build Docker package. Docker tools build image. Yes, it does. Yeah, so that's not. It doesn't include overlays or anything like that. Unless maybe stuff was in shell actually. Let's check if things are in shell. Solution, build project, and shell. Yeah, there's some stuff in there. Definitely dash Haskell rev seems to be a special one, and then it's being passed like so. Interesting. Interesting. I'll be as build inputs. So could we just let these things, I think we tried this before, but not with this syntax, not going in and then .haskell packages. So let's see whether that leads us anywhere. So we would define accelerate. Okay, do this. Accelerate and accelerate LLVM like so. What we call them don't check, for instance, in case that matters. Then we would call them below, but here we do don't check an HS call package, so it's not the same syntax, but maybe we just add them like so. That's the first thing to try. And we can also put them here just to see whether actually it does what we expect them to do, and we can check in the REPL. Sure thing. Here will be packages this time. So definitely a copy paste error, but at least we know it's executed. And here we don't have overlays. Very true. And accelerate don't check has the package thing, and that's it, nothing in there. So does call package actually return what we're expecting? Is this even working? Why is it not erroring is the other question. So can we try and just do call package ourselves? Okay, HS will be packages dot packages dot Haskell. That's not in here. I thought I inherit packages. Dot Haskell. Oh, is that the problem? Do I actually need to do dot system? Probably need to. I think like so. Okay, let's quit. Accelerate, don't check. That still doesn't have anything in it. Is it that we need to evaluate it somehow? Doesn't change it. Doesn't change anything. Okay, so let's try, and by the way, this should also fail, and so should this, right? If we don't have the system thing in it. Which is probably why this was done like this before. Huh. Okay, so new thought, new thinking here. This is not packages. This is Nix packages prime. Do you want to do that? And we move you to the top, and we do packages from you. And then those packages should work, maybe. Let's try that. Accelerate, don't check. Well, not here, but let's see. What about my Haskell packages? What's in there? That has the stuff. Let's do check true. Do we want to retry the overlay with the fix with the packages thing? probably we do, yes. So let's try that. Okay. It means we can actually try packages here. It's maybe not the best form, but I think it's probably fine. And then we just want to make sure we add. There is actually a recursive definition here, but maybe it just works. That's true. We don't need these anymore. And that's still true. Why does packages have still the architectures underneath there? In theory, packages should be the next packages .legacy package .system already. So when we inherit it below, why would it show the architecture here? Doesn't make any sense. Doesn't make any sense. Output mix packages. Shall we just inherit mix packages and see what's up? So that has the expected architecture, and then legacy package has also the expected architecture flag. So is that the issue? The fact that we have it twice? So somehow when we do this equality, we're not sure. We're not sure what happens. But what's up? Here we need to do Haskell.lib stuff and whatnot, right? Yeah, or Haskell.packages or Haskell packages. Don't know if Haskell packages and Haskell.packages is different at this point. Still don't know that. It seems like maybe not, right? Because that's what's accelerate dot, and then dot. What? Oh, right. This is indexed by. Is that the difference then? What it's indexed by? Because it might be, huh? Because it looks like it's exactly the same thing. Local archive, user hook version. Yeah, it is exactly the same thing. So you'd think that Haskell packages is the version that's sort of local. But this double system thing is confusing me because it makes me think that maybe we need to qualify this a second time here. somehow. Let's try this. See if completely crazy. And that would be prime, in fact. But even so, it's not it. By the way, the architecture is x86. It's not a arch. Yeah, what am I going into? I'm going into the ARM architecture. Okay, so definitely not where I should be checking. So let's go and check instead elsewhere. So okay, so that doesn't have legacy packages. Why? Okay, maybe this is what it's meant to be. And x86 and Haskell packages dot accelerate. Oh, that's not there. Oh, this is though. 10.4 and exit. Oh, this is also not there. How strange. So is that the overlay actually working, but I don't know. GC version, go packages override. Yeah, let's try again this. Okay, I suppose we can try both, right? We can try to also have this at the root and maybe only have accelerate don't check imported here, but I want to check out what goes on with this don't check call here, and in which case here it will be packages. See if we can get that to actually work. Accelerate don't check. I'm still doing this, but this is where we want to check, and there's nothing in there. Because the attribute lib is missing. Which I suppose is true, because we need the dot system for some reason. I wonder if this is the correct way of importing them. I'm a little bit lost. Okay, so in this case, maybe you want this. Sorry, don't check. attribute is missing from packages, so still not that. So could it be because our overlay is just completely broken? That's also possible, right? KG does claim to have this, and it does have Haskell lib, and has Haskell lib on check. So why don't you find it? Is it because it needs to be evaluated? Okay, flake overlays. Is there something I'm missing about how you do overlays with flake? With the flake. Output gets these packages. Supported systems. That's like a different way to do the system import, unfortunately. And overlay gets there, and then it gets used here with an import next packages. So we know next packages is imported, then it does inherit the systems, then it does inherit the overlay. Although maybe what we want to do is be a little bit clearer about the overlays and say overlay equal, but I think that's really the same thing. You know, I'm now starting to wonder whether this is properly placed. Packages equal next packages legacy packages system. So that's different already, and in here there isn't an import, which is strange. We don't know what flats entry does. Maybe it does the import. Extracts insist on having a flat attribute set of derivation in various places like packages and checks attributes. This function traverses a tree of attributes. Only returns the derivation with the flats and key space. I don't really want to care about this. Okay, let's try and see whether we can find an each default system and overlay. Yeah, that's inconsistent with what we have. But then when we look at packages, let's reload. Does it save, right? Yes. When we look at packages, they still have the system attribute, which doesn't seem like it should. Also note that system isn't there. Okay, so maybe that's the main difference there. Nope, it's missing the current system. So what then? So this is wrong. It must be wrong. Let's search for some other source. Inherit system, Reddish default system. Yeah, so clearly we need to inherit system here. How strange. Okay, let's see. So packages still has this, and it has the Haskell packages. And does it have the Haskell packages? It does. Or does it have the? Oh, but that's empty for some reason. Huh. I wonder whether this should be Haskell packages here. Let's try it. That doesn't look right. But let's do it without the overlay and see. Yeah, those are all the so. So it's unclear how we get let's backtrack a bit. Here, Haskell packages is packages.haskell.packages blah using override. And then SHA-4. Why am I not using that here? Why not use these overrides? So here I'm not using the overlays, so let's comment them out. I'm actually using my Haskell packages, and that's how I create the shell. Okay. So let's next develop, see where that takes us. Okay, yeah, that makes sense. I suppose we wouldn't need that, because in theory, it would be the my Haskell packages that are the environment that the shell is created with. So those should already have the patch stuff. I mean, I also should make it clear that we still haven't succeeded in making, also seeing any do check false for many of these attempts. So it could be that, in fact, we're not replacing accelerate VM. Oh, I actually shouldn't be don't check here, right? Should be the proper ones if we're overriding them. So let's quit that, and let's still REPL, and let's try and see that at least in my Haskell packages we have the don't check, or the do check false. Okay, so this doesn't work, but it's overriding the right thing. So that's some good news, I suppose. The question being, so let's see where this .override function comes from. pkgs x86 linux.haskell.lib, is that right? No, Haskell packages, GGC version, packages, GGC 8.10.4, and override. Hold on, is that? Oh, packages, package, override. That's in libtrivial.nix. what I'm thinking is that we don't need the system here because we do pkgs.haskell and that seems to actually run fine. Which I still don't understand exactly how that works. And however, no, I think that's fine, but here, like the call package, I'm thinking maybe it's also in haskell.lib. Let's check this. It's not, so it's really supposed to be in Haskell packages. It is, okay. But in that case, maybe we just do pkgs.haskell packages instead, so that we don't introduce this new HS thing, which is not necessarily needed now. Let's try it that way. Build input is with HS, so okay, so now in theory, my Haskell packages this still doesn't work, but we go further down, which is values of function, while set was expected. And which is it? Is it call package or override? Okay, let's go check again the discourse. So the override, yeah, it's supposed to take a function. So I think that's the same thing, the same error. It takes an old. Yeah, we tried this here. And okay, so still not good. So it is with it is override, but values a function was as expected. Okay, so let's use that. Right, so self is not right. Self here is supposed to be the overlay, so we can just probably just make it packages, I think. And that comes back to the same error message. So could it be we do don't check with these things? Let's check again the arguments for don't check. Right, so here we want to search using this don't check, and we have an example here, co-hackage direct or co-hackage. Oh, but check this out, co-hackage doesn't take an attribute set. Co-hackage takes only a version and a name. Okay, so we had that wrong the whole time. Yeah, like so. And then accelerate the version, and I suppose it makes sense to have right, yeah, I suppose it makes sense to have a semicolon. Oh right, yeah, no, I'm being a bit too radical here. I'm forgetting this. Okay, that looks credible. Let's try it. Still exactly the same issue, which is that override here rather than, I think, below. So we are passing a function. Let's see. This DRV with tools is a very strange way to do the overlay, which I don't really understand. It's calling call cabaltonics with the overlay thing, and so that's something we are simply not doing, and which obviously we should be doing. So okay, so my Haskell packages is how we derive the basis for the call cabaltonics. I suppose that makes sense. Yeah, except it's packages dot because it assumed that we have the overlay. Okay, so let's try again with the overlay thing. Yeah, I think there's an issue because I picked up this other example for the flake specifically that uses this override there for accelerate examples. So there's a knot. I don't know how to solve it. I don't know which way to go, but I suppose I should just try and follow more of this. The problem being that doing that, we things might not work for flakes. kind of want to try this. Is that a thing? Package? Why are we missing? Oh. That's a lambda. Haskell module make package set mix. Module make package set mix. Call package name version, and then so is it a thing where we do this? It looks like it is. Call package keep deriver. Ooh, boom, exploded. Not found in archive. I see. Okay, well, I suppose if it had ever executed call package, then we would have seen that error. So we were calling it the wrong way all the time, it looks like. Call package direct takes this set of things. In self call about to next. Error package blah. I suppose let's try with the alright, I need to reset everything here. And try with an additional .0, I think. Yeah. So a dot do check is true. Okay, okay, yes, yes. And now we do don't check. We do don't check A. It has gone missing. Yeah, right. All right, then we make that B maybe, and then B dot do check. False. Okay, a little bit of sanity after this wild goose chase. Okay, so maybe this then. I think we have another problem with how we do overlays, but maybe now we can revert back to some of these other methods. Maybe. Let's see. So here my Haskell package dot x86 dot accelerate. Yeah. Oh, that unfortunately it exits. Oh, because we need the dots, an additional dot zero. And we need to reset. Right, so my Haskell packages dot x86 Linux dot accelerate dot do check. False. Exactly what I would like. So that's good. But I think if we try to build that, we'll bump into the same error than before. Let's just take a look at it again and then see which way we're going to sort of backtrack here. Now we have make ourselves a little bit more sane with regards to how we're overriding the package. Okay, it looks like it's actually building. So I did have a concern, but maybe it's just gonna work. That would be nice. Call about that next. So there's a loop tying thing there, but I suppose it can be resolved, but my Haskell packages depend on PKG and PKG depend on my Haskell packages. But apparently it's not a problem. Which it shouldn't be. I suppose, you know, if it's done lazily, then it should work out. It should start with my Haskell packages, should do what it needs to do, and then when it arrives here, then it says, okay, what's PKG? And then it will evaluate callkabout to Nix, which already exists. So no problem with that. It just proceeds. So I think if we get it right, I would still probably want to try and do it with overlays. Maybe. No, maybe not. Install phase. I think that's good news. Yes, NDVM. We've never been that far. It's still working on accelerate, but okay. Yep, I think that's good. So now it's missing a system dependency, but that's probably fine. But CUFFT, so maybe that's actually in the CUDA toolkit. Let's see. Nix packages and CUFFT. It's not free, and solver. Don't distribute. There's no reason why it shouldn't be available. CUDA toolkit is not installed here, but if I do something like mixenv, that's not what I want to do. Mix override cabal. Okay, let's take a look at this. This looks interesting. Just export CUDA toolkit. So it should be, yeah, it should be a dependency of so maybe it's just that we need to explicitly import the CUDA toolkit. It seems like it was imported, right? So is there another CUFFT? Nope, not here. But why is this on GitLab? It's not into the original mix packages on GitHub. It is with the same blurb. Example depends on CUDA toolkit and no, example of using library using CUDA. Building per CUDA toolkit. Let's get the long form log. So it's trying to build, I think, the Haskell package CUFFT. Version 0.10.0. Okay, so 0.9 is the published one, but I suppose Cabal is, oh, it's 0.9.0.1 here. Interesting. How? Where does it get this from? Could it be because of the override for CUFFT with the override Cabal thing? Let's see, override Cabal, make it so that there's a pre-configured step importing the CUDA path, which in turn should mean then that with the is it the build depends? There's a custom setup, so it will be in the custom setup. CUFFT. CUDA library path. Okay. So let's go into our REPL again. Let's see how we're going to my Haskell packages CUFFT. Where we have here. Well, we want to check that the pre-configure is correct. Looks correct to me. Let's export the CUDA path. So what, huh? Okay, let's take a slightly different tack. Let's see whether we actually really need the FFT stuff, or because here, for instance, we have FFT, we do, and it's deactivated. So yeah, the Cabal2 Nix doesn't load the Cabal.project file. Let's look at what alternative do we have to deal with that. There we go, support Cabal project files. Unfortunately, that hasn't really moved forward, and that's a big limitation. Oh, there's a patch. Time has been lacking. Rips the install plan out, and Haskell construct some expressions. Ooh, and that's an old thing. Is that the correct Cabal for next, though? That's a question. Because it's not obvious. Dash Cabal project. Oh, so there is presumably something. Fully specified dependencies for 8.9. Ideally also Cabal project. Okay, well, in absence of that, let's change the default flags. Something I don't really want to do, but that would help out. So let's just get dot flags into a separate window. Oh yeah, open to the side. Wow, how funny. Open to the side. Okay. Alright, so that's not the one we wanted. We wanted the Cabal project. Okay, so false, and that's not going to be great for any other project, which is a little bit terrible. EKG, sure, false. LVM CPU, false. PTX, true. And then sparse matrix. That you're allowed to bypass the FFT stuff for now. NBody we keep. But yeah, making Cabal project work, that's going to be needed if we want to use this thing elsewhere. Okay, let's also not clear why CUFFT wouldn't work, right? Let's take a look at what's in the path real quick. Could it be this extraneous carriage return there? Lib CU. Let's see, lib CU. FFT. Yeah, plenty of libc FFT right there. I wonder whether it could just be the carriage return. Is there a way that we can rewrite the override cabal somehow? That's all. Today's weather is pretty ruthless. So is it pkgs.CUDA toolkit that has that carriage return? And how would we know? I suppose we could try our REPL again, right? Then what? Then CUDA toolkit 10.2. What's the value of that? Yeah, I think the interpolation of variables there, I don't know how we can, I don't know how we can make that work. How we can test what that extrapolates to. Dot outpath probably. That doesn't have a backslash. And by the way, NVVM I think built correctly, right? At least it was on its way. It could have stopped before it completed. Maybe it would have ran into the same issue. Can we do the same trick? Can we try an override, but some try and trim this, or use the toolkit 10.2.outpath. Shall we try CUDA toolkit.outpath? No, same thing. So I think we could try copy paste that, add it to the list of our overridden things in the flake, which I suppose would mean here, right? Maybe. And override cabal, where does this come from? With Haskell.lib, right? So pkgs.haskell.lib. I'm just trying to check. Yeah, it is strange, right? I mean, is it though? Let's try this on the command line. Okay. Yeah, there's a chance that it be mangled. I mean, you know, I'm not completely positive. I think it must depend a little bit on how the interpolation is done, but there's definitely a chance. So we try it like this, maybe. Whoa. And we REPL again. Okay, super doesn't work, which makes sense. Well, in this case, is it actually H super? I don't know. How would we know? We would go into my Haskell packages and the system, and let's say CUFFT, that's current focus, and pre-configure. Clean. So let's try again with the -L. So at least we'll have removed that source of potential issue. Well, we see that NVVM seems to be happy. Well, no, that's not clear. No, it does start to compile. And here we don't actually have CUFFT getting started. Oh, but of course, because I commented it out. Okay. Okay, let's stop the build and let's get it back in. Let's see whether we're able to actually fix stuff properly. Nope. Okay. We are not testing FFT, so let's try and move forward instead. Maybe note a few things that we are experiencing here. So call cabal2nix doesn't handle cabal.project files. CUFFT package doesn't find the C library CUFFT despite the CUDA path being provided. Well, I'm now thinking, hold on, usually wouldn't you want this like maybe in LD libraries or something like that? Shouldn't we try and add that then maybe? LD library path or something. Well, I mean, the fact that Accelerate compiles, and plus it compiles our famous template Haskell thingies, which is very good. Because if we bump again into that problem, then I would definitely be a little bit unhappy. But I think we're making progress here. Again, maybe finally rise above the system, our system problems, and get into Haskell land finally. Let's look at exactly what the CUFFT error messages was CFFT missing or bad C library. In a non-standard location. Yeah, we don't know exactly what that means. Oh, accelerate is rebuilding. 104, yeah. I'm not sure why here. Maybe for a different backend. Let's see. There's what does the cabal? I mean, looks like libraries in any case. So could it be that we messed up a bit our flake, and so it's building it twice? It's possible, but you would think that Nix would be able to know that. Well, let's look at the cabal file. Library is no fib thing. This drastically improves build times for some reason. Oh, I didn't read that. Oh, interesting. Why? We're comparing the zip width from accelerate. Excessive and unproductive and mining. Test that no fib module also takes a very large amount of time. Worth with GHC88. Okay, come on. Haddock. Okay, seems to progress. And yeah, this is not reassuring, but it is what it is. And I suppose we can oh, false prime, no, not gonna work. And yeah, the fact that we can't use Cabal project file is going to be a problem, but maybe with our other projects. But in other projects we're actually using Haskell.nix, and it actually works with the GStreamer project, so maybe we'll stick with that. I think it might be I mean, it will cost us a bit for context switching, but once it works, we shouldn't have to tamper with it too much, and at least then we can continue evaluating both. Also with things like incremental compiles and so on, and whether the caching is good or not. Yeah, we should have skipped the haddock. So don't check was maybe not sufficient. Enough mix. This is with who go false, but that's for accelerated example. So here we don't check. I think if we added the static executable, which is a bit strange because this is a library, but yeah. Oh, there might be a way to just use override cabal there again, somehow. Not sure how. It's good to know that that this works though, this override cabal. And okay, we're getting further. Okay, so those are dependencies of the accelerate examples, I'm pretty sure, like length and linear accelerate. Let's look at the cabal file. Yes, they are. So we might not need all of them. In fact, maybe in fact, a lot of them should just be deactivated. So I'm not sure why they would be compiled, but I suppose length, linear, and WC, all of these are present in the NBody example, so it makes sense that they would be. Okay, accelerated LVM, that's another big one. That's the CUDA linking one. So if we pass that, then we're kind of out of the woods, I would say. But this has worked well on Linux so far. So, meaning once we get the CUDA library to install properly and that CUDA.buildinfo to be generated, then things seem to be working pretty well. Aha. There is a recipe for building with Cabal projects, so let's log this. Maybe we should test this, but maybe later. Hey, LLVM. Oh, so maybe it is LLVM PTX actually that does the CUDA linking. Accelerated LLVM, I think, links to LLVM native. Sounds right. These terms are a bit mystifying. I'm not sure where they come from. Accelerate LLVM PTX. Probably the LLVM-isms. NVPTX. PTX. There might be NVIDIA-isms. Interesting. we'll see what the default gives us. Of course, last time we tried to run this, then we also bumped into a sec fault. And at the time, I thought maybe it was linked to the version of the driver. That's still when we were trying to build with stack, I think. So we might end up in the same place. We shall see. Oh, no fib is back because accelerated RVM PTX also needs the patch. Fine, we know how to do that. Hopefully it'll only rebuild the very latest stuff. Yes. It still has 46 modules to compile, but hopefully no test this time. Why is it rebuilding in VVM? I'm not sure, but it's starting with PTX. Okay. Okay, I'll take a small break and I'll be back soon. All right, and I'm back, and take a look at this. It seems like we have entered the Nix shell. So that's good. I was a bit worried that it was going to build GHC there, but it didn't. It probably is just maybe updating the GHC package database there. So what do? Well, we cabal build, I suppose, and yeah. And then we'll cabal run NBody, I suppose. Looks like it's on its way to rebuild a bunch of stuff that it should have already built. Maybe we'll find out that it has already built them and not rebuild them. What it does say requires build. Here it did say that it kind of propagated the build inputs, but well. Oh, it says completed. Okay, so maybe actually there's something a bit Nixy going on behind the scenes there, but that makes it so that even though it says that it requires the build, it just checks and it's like, oh, okay, it's actually there. Maybe something like that. I suppose what matters maybe most is how the incremental build workflow is going to be. Where if it tells us this each rebuild, then that's not acceptable for like production development environment. Here though, it looks like it's it knows that it needs to build the accelerated NBody executable, so that's good. It lacks a bit of feedback there, right? I wonder whether it's actually should go into this new style and is it what's happening? Was it cross compiling? What? Oh no, that's probably from our previous experiments, I would imagine. However, there's nothing in the there's something in setup here, but nothing in build. We are compiling the NBody. No, not yet. Oh, no. NVCC. Failed to build CUDA. I was trying to rebuild CUDA here and it fails. Ah, damn it. Cool. CUDA path. That's almost correct. It has the /n thing, which we're not sure whether it's a problem or not, but NVCC is not in the path. What's in the path? Tons of stuff. Anything related to the CUDA toolkit? CUDA? No. So I remember we bumped into this in the past, and that's one of the reasons I think we had to, in fact, either do this or this. One of these two, I think, allowed us to put NVCC in the path. How about if we just put the CUDA toolkit here? I wonder whether that would just work. Let's try it. Doesn't know where to get that because it's supposed to get that from the Haskell packages. Whoopsie. That was my phone. Okay, so I think it needs to go into the native build inputs, I think. So let's try that. Native build inputs equals pkgs dot blah, I suppose. To be honest, I think it would also work with just pkg's CUDA toolkit in here. So let's try that instead. Okay, well, there's a bunch of CUDA things. Oh, and then VCC is here. So let's go for Cabal build then. Oh. Yeah, I remember something about that. Definitely remember something about that. Yes. Well, the weird thing is that CUDA did install itself completely properly. Okay, let's try this instead. Don't have a lot of trust in this, but I suppose it's worth a shot. And let's try that again. Yeah, it fails. Find the CUDA toolkit, but then try and find this path. I remember, is that something where we actually changed? That was in the setup code, I'm pretty sure. And it's, if it doesn't match with that x86, yeah, by default, then it assumes x64 if it's an x86 64. So how did we deal with that? We could just change that code, right? That's one possibility. The other is to symlink lib64 to lib. I wonder if that's what we did. And if we did, then where did we do that? Would that have been here? No, right? That's something I already deleted. Could very well be. Let's see. So instead of overriding, or maybe as part of overriding Cabal, I mean, I think we'd want to patch CUDA itself. Which is part of, I think, what we were trying to do here. Which would maybe make the library available elsewhere, because I think there were several ways to resolve that path. There was this, but then I think there's some write-up about the way that it can be found elsewhere. But maybe it's about finding the library path, not finding or finding the toolkit path, not the library path. Yeah, that dates from when we were building on Windows. Okay. Okay, well, I suppose we could just do, we're not using CUFFT anymore, so we could overwrite CUDA such that it would do some additional configure step. We'd want to make sure that we don't override an existing configure step, so let's try and see whether there is one already inside CUDA. Also, this seems to override Cabal for some reason. Instead, I would expect that it would be overriding the package itself. But I suppose everything in the package ecosystem is slightly different. So I think this is what we want. I think this is equivalent to my Haskell packages these days. And then we check out CUDA and pre-configure. Okay, so it already has that thing in it. And then I suppose we just we ln minus s this lib64 and this lib. Yeah, I think that's the right way. I think so. Try. Yeah, so hold on. Yeah, it's not clear that this even works. Well, you know what? Let's do it. Let's mutate for now. Let's just see whether we're on the right track or not. So is that the way to do it? Yeah, but anyway, that's the proper way to do it, I think. Except that we probably want to actually go directly below here. But the problem is that this seems to not pick up those changes for some reason. Yeah. Could I use the Haskell package already correctly here? Maybe we don't do pre-configure, but post. How do we even rerun it? In theory, it's in my Haskell packages, so it should be in the shell. But let's try with the REPL again. With my Haskell packages and x86 Linux and CUDA pre-configure. Yeah, it does have those two things, but we don't know whether they actually are ran. I mean, this leads me to believe that they would be, but for clearly when we go back to Unix develop, it's not in there. Let's try and put something else maybe in the path, like echo export June was here equals true, and see whether anything happens there. It does look like it's rebuilding something. But no. Doesn't go in the environment at least. Ah, right. So, yeah. Okay, I see. So maybe if it needs to be persisted in the shell, then maybe we need something else to occur. Plus, all of these paths might not already exist before it's built. So maybe we do, well, we go back into the shell and we try out something like a different path here. Like, it seems like there's mostly pre's. There's a post patch. What are the patches? No patches. The post patch. No post patch. What about the pre-install phases? The haddock phase. And the the out path, we know it's install path. What about the install phase? Run hook post install. So there is possibly a post install hook. It's just that there's none here. So let's make one. See whether that actually gets us somewhere. Yeah, there is a post install now. So does it run? Apparently not. Apparently not. Hold on. Not CUDA, CUDA toolkit. So that sounds like a proper overlay. Overlays equal, let's do it differently. CUDA toolkit. Maybe we should make this a bit easier to read. And then we shall say CUDA toolkit will somehow override, but how do we override post install? Right, well, it's a final prev thing. That's one thing. Oopsie. And then we just need to find the override syntax, the simple override syntax. But really, what should it be? It should just be that we replace CUDA toolkit by prev.CUDA toolkit. Is there a toolkit somewhere in here? Toolkit, yes. Toolkit. With the post install, is that too? Will that just work or what? And right, so there's this, and then there's this, right? Let's try it. Let's exit here, and I suppose the ROP. Right, yeah, we need it. Proper lambda here. And still not, and apparently. How do we check? We do our well, try and go into the REPL. Obviously, we need to refer back to how overlays work, and it's using override. Dot override. Oh hey, Sidewho, thanks a lot for following. Really appreciate it. Do you do some Haskell as well? Maybe some Nix? That looks credible. So okay, maybe I should just go into develop and trust that maybe it will work. Hey, at least it knows that there's some post-install thing. So that's, I think, good. Do we need to specify 10.2? We might need to specify 10.2. So let's specify 10.2 here specifically. I don't know that that's going to work, but we shall try. Called with unexpected argument. Okay, next overlay post install. We might need to override ATTRs without triggering rebuild. We don't want that, but maybe there'll be some instructions on how to do it. Nope. Well, you should never ever use NixOS. What? Reprogramming post install wasn't fun. Okay, I have overlays. Okay, well, I don't know if I should do this here. I can use as a source of info. I'm not sure is the right thing. Is there? There's no post install. Applying overlays. We know how to apply them. Adding patch, overriding package inside the scope. Changing compilation option. It could be that we do want to override ATTRs. Yeah, I think that's what we want actually. Override ATTRs, but then we need first to wrap this and then pass the function, even if we're not going to use it, I think. Yeah, src equal super. Yep, that sounds right. Let's try this. The fact that it's rebuilding CUDA toolkit is good because the derivation has changed now. How do we bash here? the CUDA Haskell package expects the CUDA libs to be in lib64. So I redo this. We probably want to use systems here. Hey, all right. Well, you are definitely trying to do it, which is awesome. But you rename. So hold on. Are you saying there is a lib64? Seems like that to me. No, there's something that renames things from lib64 to lib. But that seems to be a different path URL than this one. So where is this one coming from? And it looks like we're trying to create a symlink in maybe then another. So maybe those are layers. Can we even, are these still existing? They are, and well, there's no lib64 in here. Okay, let's try some of the other ones. Let's try this one. It seems like it has a lib64 in it. Could it be just like the source folder? Well, it doesn't have a lib64 here. Well, but it's been renamed though, but the fact that these paths are different is a little bit confusing. Okay. Exactly that. Exactly right. So we need to patch something deeper, I think. Maybe we need to replace the whole lib renaming inside. Let's see, returning to the Haskell engine. Yeah, no, that's not related to that. System headers live in a non-standard location. Yeah, they do. Okay, so CUDA toolkit, and let's look at the recipe, see if we can change it. 10.2 samples is not what we want, and that's probably in here. 10.2, and so it uses this common thing, and then it would do anything related to lib64 right here, for instance. This and also this, and it makes the lib64 folder during the install phase, but then it removes them. I think, right? MV lib64 to outlib right there. For version, at least version 10.1. So all that gets MV'd. Right, so maybe it's just out here. Is that how? Maybe that's really how things are. Or we'll have a problem doing that. Yeah, first of all, let's just do the row out right there. Okay, let's try that. Move some libraries to the lib output so that programs that depend on them don't pull in this entire monstrosity. Okay, I suppose maybe we could do this then, because maybe this is actually the lib output we're looking at, not the out output, because that would explain why there were a number of paths. This would be out, and then this would be kind of the output out. Oh no, this would be lib. NZ would be lib. And then here would be using something completely different, which shouldn't be used from here. So maybe this is going to work, but maybe we're going to want to somehow to use lib instead than out here. Although this, okay, this, unfortunately we still don't have that. But what do we have in, well, what do we have in the CUDA path? Huh. So this this /n is actually causing some issues, at least here. And there's no lib64 here. Oh, okay, but that's probably because we went into the output folder, not the lib folder. So let's create lib64 here. How would that work? You might want to do lib here as well. Let's try this instead. Okay. At least no permission errors this time, so I think we're doing the patching in the right approach. Yeah, so let's hope that this is lib. How would we, maybe we would know, because maybe CUDA path is set here. Strangely enough. enough, it is not. That is very strange. Yeah, it's very strange. Why is it not set here? Oh, it's the sandbox model, I bet you. The reason why we don't see June was here, it's the sandbox model, pretty sure. Okay, and well, let's. It could be that it's not the same CUDA path, right? For WD, it is the same. I mean, at least it's the same in the CUDA path, but is this really the one we want? Or should we do CUDA path 10.2 here? And is that important? Same CUDA path. But we don't know who wins. It could be that we actually need to override. We don't know where the CUDA path comes from. Which is an interesting thing. Let's do Nix REPL again. Because this stuff is usually part of the out, right? Is there an out here? An outputs, but no, out is not what we want. Oh, there's a derivation. It's true. Interesting. And false. What's our path? What's in there? Okay. That's us. the question is, how do we know in an X-flake where does n variable come from? Is that even needed? I actually doubt that this is needed. We saw we were modifying this, but I suppose, yeah, I suppose we do need to override accelerate examples instead. So let's try that. We can probably do override cabal and then nothing. I would think that it's possible to do that. It's a bit strange that we override cabal, but it's not completely absurd, I don't think. We'll basically say, yeah, you create something with cabal tunics right there, and we wrap it. Or it could be that actually just adding the pre-configure here. Actually, maybe pre-configure is not the right it should be a post install probably as well. We don't know whether this thing has happened or not, because what I suspect is that this path is in fact is not the right path. It's not where this lib gets output. Obviously, otherwise we'd see it here. Let's see what the other path we had were. This was what? This is the dash lib, and you see that we don't use the dash lib. So it could be that in fact what we want is out here. So let's try this. Let's try to copy from the dash lib to the out. And I will take a small break here and be right back. Okay, let's get back to it for just a little bit more, and I have food coming my way. All right, let's see. That path is still the same, and is there anything new in it? There isn't. So, So out must not be the out we thought. So let's look at the out that was there. How about that? Oh no, but that wasn't an out. That was so that must have been an out, maybe. That seems like that was more like an in, if there is such a thing. But yeah, there's no lib64 in there. Okay, so let's think about the overlay logic here. CUDA toolkit's supposed to be an overlay, and we pass it to overlays, and it goes into packages, and then that should mean that when it's depended upon, which should be the case through here, but also through some of the existing libraries, because it seemed like it was pulled in, the dependency. I actually don't know exactly how. Maybe the CUDA package actually does include it as a dependency. Something we might need to figure out in order to know exactly what pulls it. I think that might be something that makes sense. So if we search for CUDA toolkit, then we should have some stuff that actually matches Haskell. Not here. Not here. Not here. Quite a number of them. But here. And that would be for what? For... Oh, there's a CUDA home. Oh, I don't, hold on. Whoa, I must be tired. I think I saw CUDA home there. All right. CUDA path. So, right. So CUDA actually does call CUDA toolkit. And I think, yeah, and NVIDIA X11. So that's how we get those dependencies injected. And that's how we get our slash. And the extra libs there, right there. But with CUDA toolkit.lib here, as you can see. Yeah, I'm a bit confused now, because if that's the case, then this extra libs dir should be passed. So is it this problem with the fact that when we do cabetta.build, then maybe it's not passed here? We need the extra libs here. And so it's this kind of disconnect between the fact that between the shell, I suppose, where we have available in the shell, which in theory, so could it be that we actually don't bring in the necessary dependent packages somehow? because it is strange that we have to rebuild these things. Okay, one thing I could try is to clean Cabal. I'm also going to just clean a bunch of stuff there. I don't want that stack work anymore, nor the actual dist folder. This is all confusing. So yeah, so obviously not obviously, but when we run Cabal run in this shell, then what it seems like is that we won't have those overrides that we need, like those. And if we had them, then it would just work. So why don't we have them is a question. And I suppose that Haskell.nix did override the package database, but that's not what the Cabal to Nix does. So I think what this means is that maybe I can't Nix develop, but maybe I can just Nix build. Something I haven't tried yet. Wow, completely different error. Bin utils wrapper? Okay. Not clear at all. Okay, so let's take a look here. About to next. So yeah, so in this case, it's DRV with tools. And I think building this or doing Nixenv with this then just drops into something which has built everything using Nix. But maybe including yeah, I still don't understand how, when, for instance, when we do Nix develop and it rebuilds, or it built the Cabal library, then I presume that this goes, oh sorry, the CUDA library, or even the accelerated LVM library, where does this go? I mean, it goes into the Nix store, but how is it supposed to be picked up? I mean, during a normal build, I suppose it's meant to be picked up by... No, I don't even know how it's meant to be picked up. How does Cabal then pick it up? Is it just the way my Haskell packages are interpreted by Nix? Like there's just a standard way, if you pass in something with my in the Haskell.packages namespace, then there's a special way in which these things get built. All right, 1 second, I'll be right back. Okay, so my food is here, so let's just try one more thing and then call it a day. So I was reading through this, see if I could understand something about the way packages are built. GC with packages. We create the derivation for your project. Uses my Haskell packages to modify with the overlay. Convert a Cabal file into a Nix derivation without us having to call Cabal to Nix ourselves externally. Note. This also works if you had just a project.yaml, but you have to set the path to // instead of name of Cabal blah or package YAML. I wish it would. To have the unintended consequences of extra rebuild, since Nix is importing the current directory and all its subdirectories as dependency of the project. In this case, since filter source blah blah can be used to filter out unwanted files. I see. Lastly, we have the environment for the shell. This is made for you by call Cabal to Nix. It is in the env attribute of drv. However, I want to add some extra packages for development, namely GCID. So this is what we do here, right? With these build inputs. Using shell 4. Which means that yeah, if we Nix develop, we have things like Omulu in there. Yeah. Shall we try and find out what this shell 4 thing does? I think it was linked somewhere in that post. Oh no, don't leave me this search, please. Shell 4. Okay, returns a derivation whose environment contains a GHC with only the dependencies of packages listed in packages, not the packages themselves. Right, so that's so in theory it means that given that accelerated example depends on for instance CUDA, then CUDA should be pulled in as a dependency, which it seems like it is. But then the question is, why does it rebuild it when we Cabal build, right? Oh, Cabal.project. I didn't think it worked with Cabal project file. Hold on. Using Nix shell on this derivation will give you an environment suitable for developing the listed packages with an incremental tool like Cabal install. So let's see, Cabal, can we list packages matching a search string, info, user config. I suppose we can maybe list, for instance, well, CUDA, how about that? It says it's not installed. And that, I suppose, is where things are weird, right? Or is it that... No, right? Because Cabal really is Cabal install, right? Yeah. think so. But then, okay, is it that remote build reporting? Is it that we should remove our cabal config file? Let's maybe do that. And then we don't have a cabal file. But then boom, it writes one. Okay. But it's one with a package repository that is obviously not local. I mean, yeah, that is not in the Nix develop sandbox. So where are these things? Because if we said that either of these things were in the proper place, then I suppose that that would work, right? Okay. Cabal inside a Nix shell. Right, cabal inside Nix shell. To enable Nix integration, simply press enable Nix global option when you call cabal. No, just enable Nix. Not installed. So that doesn't help. Aha, it does need a shell. Okay. We can do that with the flake compat thing. Flakes wiki. Okay. Compat and it will be this and shell mix. So I think it means we need to do it from here. Not installed. Let's try Nix shell. And then cabal-less CUDA. Not installed. Enable Nix. Still not installed. So let's go back to Nix. difficult to make it more confusing. Nix style builds have nothing to do with Nix integration. Kibana has the ability to integrate with Nix for dependency management during local package development. That's what we would want, but clearly things aren't working for us. Okay, one more Hail Mary Google search. Flake, Cabal, Nix develop, no. Flake, Nix develop, Cabal, GHC package database. Install a Haskell package this way. GC package list. Yeah, there's a bunch of stuff there, but not CUDA. So I think, yeah, GHC with packages. We've seen that GHC with packages thing. So is there an issue with how we do our overrides because we don't somehow use GHC with packages, whereas it was specified there? Let's take a look at it like here, GHC with packages in the override. Specifically, we override with packages here with blah and with Hugo there. Hold on, what? Why doesn't with packages match? Ooh, that's bad. Apparently I had a search function that would have been problematic. You don't need to do something like the following. Most people use shell for works for project with multiple packages. Also doesn't need to build input directly. GHC typically be a native build input. Okay, shall we try and pass CUDA for some reason? I don't know, that's strange, but let's next develop. And GHC package, what was it? Package list. And CUDA is here. Holy moly, what? Okay. It says first run. Okay, maybe I need to keep out clean though. Yeah, no, it still thinks that it needs to rebuild, even if it's listed here. maybe that's something special from the CUDA library because of its setup phase. I think that's correct. I think it must specify that it needs to rerun the setup phase on install. Maybe that's what the setup phase is. So in this case, this is a different path though. It has a lib64 thingy. All right, it's just not pointing in the right place because we probably need to point to this link instead. Oh, holy moly, it might work. Amazing. I wonder whether this has anything to do with it. Probably not. Let's remove it. And let's, where was it? Here. We want to do instead just this. Is that right? Yeah, basically, well, okay, let's try. This would mean that we are in the right folder. We might not be, but this might actually be sufficient. Yeah, it might actually be sufficient. So let's, oh, that's exciting, actually. Sort of works, maybe. Yeah, of course, the point that was missing when we were going down that path last time was that I didn't do a kebab build that would have spitted out the current CUDA toolkit path. And instead, I was stuck with this old path, which, to be fair though, I suppose that old path was showing up when we're doing echo CUDA path. But I think that's because echo CUDA path was set afterwards, but the CUDA path also is not the same. I don't know. It's a bit strange. You would expect this to resolve to the current CUDA toolkit, or is it because of the 10.2 thing? Doesn't sound right. Well, let's see if we succeed in getting a lib64 there. But it would still be sort of wrong, right? Because we should have CUDA already built, is what I would like. But so let's take a note of that. Okay, we did run just a tiny bit further here. Okay, so let's try and summarize where we're at. Okay, so one of the main issues is that we have to rebuild the CUDA Haskell package because of its setup phase. When we do this, though, it seems we don't have the proper environment, proper build environment. for instance, specifically, we're missing, for instance, it seems that it's the extra libs that are not being passed properly, right? These ones. Extra lib dirs might not be passed correctly. Okay, I should have to rebuild. Yeah, so it does build when building the next shell, the shell then not while in the shell. Because I suppose then the question is, how do you pass cabal overrides once you're inside the shell? So how do you respect the cabal overrides from within the shell? That's very unclear. So we could maybe work our way around it. We're missing the CUDA library. That's probably, again, simply because we need to set up include directories properly. Maybe even the CUDA toolkit is not correct. Path. Yeah, it's still 4D, whereas it should clearly be this. So what if we overwrite this? If we say export CUDA path equals this, then can we build? No. Right, so hold on. Those parameters, where are they stored? Is one of the important questions here. They might be in this new style. No, they might be in a TMP, but looks like neither. Okay, we have more data now. I can find -l CUDA, and that's because you run cc. Hold on, a GCC wrapper. Yeah, all cc things. I suppose -d CUDA install path. That looks right. Library path 64. So that's not correct, but it is what it is. Meaning that's why we fixed it, we patched it, but we probably shouldn't do it like this. We should find a way to actually respect the cabal overrides. So let's write that down. If we patch the output lib to include the lib64 path, we get a bit further, but we really should instead respect the cabal overrides. But I'm not sure if this is possible with the custom setup phase. So then, right, what we don't have is the extra include tiers. Let's include lcuda right there with a -l lib64. Right, but that's not. Actually, it's there twice. Could it okay 10 to 64? Yeah. So that doesn't make sense, right? It's there twice. And in fact, what we would want is the include folder there, because that's where the stuff lives. So of course we could probably do another workaround and do something like put the include stuff in lib64. And then it would probably work. So let's just try that. So that would be cp -s targets x. Let's copy that. 6 include out lib64. We want to copy everything. Copy cp. Like so. Which, yeah, is dirty, but if it gets us there, then why not? What if I put CUDA here? It will be a Haskell package. That's a thought. Okay, the CP doesn't seem to be. Oh, right, yeah. I think that we need to be out here. But let's try this. Let's try this interesting idea. So that would be, we would, I think, yeah, just do this. Then we put CUDA in here. Not CUDA toolkit, CUDA as a Haskell package. My thought is then entering the build environment. So you would build it as a dependency to accelerate example, and then maybe rebuild it before entering the shell and make, and therefore by doing that it would have already set it up in that new shell environment. I have no idea. Might not work at all. Yeah, we're back to the same error. So no, so this doesn't work. So let's try again with this, but hopefully with the proper CP syntax here. We probably want to CP -R, to be honest. And yeah, post install This should work. And I kind of want to see the details. And since we modified the derivation, we patch the derivation, it goes and refetches the source, or at least it sees the source is the same, so it re-unpacks it, and then it will rerun compilation and install, which is really not compilation since it's a tarball of binary libraries plus some include files. I think this should work. So the patching is to rewrite the links so that they're properly pointing to the next door. That's a standard thing, like a patch elf stuff. Except phase, I don't think we yet had the install phase. All right, I didn't see RCP, but it's probably fine. Yeah, but let's look at our lib64 here. Right. Yeah, obviously it means that it could be actually in the lib folder, which is ugly, and which probably also isn't. I mean, it must have rebuilt it with a different path if it worked. It is a different path, but apparently it didn't work. No, it looks like the includes are here. Okay, so another problem. Just can't find the CUDA library. Okay, so that's where we're at. It could be that we need to see where this CUDA build info file is. We don't have that. That's the setup, but it doesn't seem to be creating one that we can see. Of course, this should really be a find, but who knows the find syntax? Okay. So we would have seen it. I think that's just part of how Cabal does things, like not leaving those files around. would be helpful to know where it's generated, wouldn't it? Cannot find -L CUDA. CUDA library path 64. Oh, right. The other possibility is that LDD will fail on the lib CUDA. Oh, no, there's no lib CUDA. It's the error. So where is lib CUDA? Oh, it's in lib. So we need to pull in lib somehow as well, but how do we do that? Hold on, that's not what I'm looking for. This is so no, that's the library samples. Yeah, we don't care about the samples. The common in here and the lib with lib. There is an existing post install, by the way, for CUDA toolkit. So we might be overriding that. That's for this end site thing. I don't think we're hitting this, so maybe it's okay. Yeah, I think the fact that this is moved. So let's move back all that's in lib into this lib64. I mean, it's ugly, but and probably let's not do the include thing. Okay. Okay, last thing. He says. Yeah, we see that that's pointing in the right place. So how would we in fact depend on the lib? I suppose is the question we can write here. Maybe the problem is that we depend out of CUDA toolkit, but the CUDA library itself, lib CUDA RT, I think, is in lib, which I suppose is a similar question about respecting the cabal overrides, because those cabal overrides specifically have a lib as the target there. So could it be that we just need to include that? We just need to include .lib somewhere. Okay, I suppose we're gonna try something else. And cabal. Okay, let's see. Do we have a lib CUDA in there? I see UFFT right there. But oh, hold on. Yeah, I'm assuming this is the same build output, but it obviously shouldn't be. 7C. And lib 64. It has the CUDA RT and so on, but it doesn't have the but it overrides what we had in there. Yeah, of course. Or is it of course? Yeah, no, I removed the includes from there because it wasn't getting us anywhere. So instead, yeah, instead let's try the patch the other way, and then we'll stop there. This and yeah, including .lib in there, and see whether that does the trick. Yeah, you shouldn't need to rebuild the. Yeah, indeed, because everything should be there, but yeah, it just doesn't work. Okay. All right, I think probably we need to look at with packages. So let me write this there. Take a look at GHC or like with packages, which is defined, or at least oh no, that's not here. Here with packages. Somehow get the feeling that this is related. It's GHC with packages. Not sure why, but yeah. All right, so that's it for me. Seems like we still in the system mud and that we haven't risen above it in Haskell beautiful pure land. Oh well, we keep going on, and I guess we'll take a break from all of this malarkey and do some PureScript next week. So at least we know we won't be running into these problems, because even though we did have to do a little bit of nix to get PureScript to go, it is going, and you know, there's no real system dependency in JavaScript in the JavaScript world. So that's going to be nice, and I'm totally looking forward to it, and that shall be on next Tuesday. So thanks a lot for watching, and I'll see you later. Bye bye.